Okay, camera's on. How are you guys doing? Let me. Okay, we've got 9 folks. So why don't we just hold on until we get 15 or so. Thanks, Ibrahim. Appreciate it. Warren, Katrina, Esmeralda, Derek, Cameron, Devin, Kimberly. Would you all turn on your cameras if you can? Good morning. Good morning, Warren. How you doing? Okay.
I'm still eating, Professor. Sorry. I'm almost done.
Good morning, Professor.
Okay, let's wait till we get 15 kids. At 12, it's a minute past the hour. So I cut my hair this morning. I'm just wondering what it looks like. Oh, that's not great. Not great.
Recording in progress.
Welcome, Neb. Welcome, Levi. Get one more, we'll start class. Go on. Okay, that's 15. Okay, let's take a roll. Today, I'd like to ask you, what is the most interesting part of yourself? And could someone speak? I haven't heard anyone. Is that a taper?
Hello?
Hey, perfect. I can hear you guys. I tried to do a taper. Looks bad right here. So that's too bad. Yeah, I don't know. I've been cutting my hair since the pandemic, and now I'm like, well, now I don't want to go spend $25 or whatever to get my hair cut every 6 weeks. So now I just do it. I do my kids. Okay, so what's the most interesting part of your life or you? What's the most interesting thing about you? Luis Acevedo. Okay.
I didn't hear what you said. I just joined around.
Oh, what is the most interesting thing about you?
I don't know. That's a tough one. I guess I'm just willing to learn. I don't know. Pretty open-minded.
Okay, sounds good. Katrina Atkinson, what's the most interesting thing about you?
I agree. I think this one's kind of tough. I guess growing up, I was a junior Olympic gymnast.
Oh, cool. You were, say it again, junior?
Olympic gymnast.
Oh, wow, that's really cool. That's super interesting. Levi Beck.
I guess I make my own kombucha.
Oh, cool. Is that drink from like Colombia?
Yeah.
Cool. And what are the properties of kombucha?
You have like a SCOBY and you steep some tea, you throw the SCOBY in it and you wait for a while and you're good to go.
Is it good for you or does it taste good or what's the appeal? I don't know.
It has a lot of probiotics in it, so it helps with like your gut health.
Cool. Yeah, gut health is a big thing right now. Cool.
Mm-hmm.
That's super interesting. Okay, Stephanie Camacho Duarte. What's the most interesting thing about you?
I'm really into baking. So like I like to make cakes and cupcakes and cookies.
That's awesome. Have you seen The Great British Bake Off on Netflix?
No, that's like on my list of stuff to watch.
You have got to watch it. It's like one of my favorite shows.
I've seen like clips of it online, but I haven't watched like a full episode.
That's great. I also think it's a great show about civics. They're just like super nice to each other as they're competing. And I just think like it's a really great kind of example of how to treat each other. I think it's a great show. Cool. What's your favorite thing to make?
Lately I've been making a lot of cake pops.
Oh, cool. Very cool. Okay. Alondra Carrillo. Yesenia de la Cruz.
Hi, I came a little bit late. The question was, what's the most interesting thing about me?
Yep.
I don't know. I have this weird thing. I don't know if you guys know what it is. I have trigger finger, which is basically like my thumb is like permanently locked in like this
Oh.
position.
What does it come from?
I honestly don't know. I've had it since I was like little, and like I guess you can correct it with like surgery, but you don't have to if like it doesn't really like bother you. So
It doesn't hurt. It's just a little bit bent.
yeah.
Gotcha. Cool. Super interesting. Ibrahim El Shahawi.
I guess I would say like a or a pretty average or like a pretty good powerlifter. I just recently won a powerlifting meet locally.
Whoa, that's very cool. So this is where you're lifting weights from the ground to above your head. Is that?
It's just focused around 3 lifts: the deadlift, the squat, and the bench.
Very cool.
Yeah.
And where did you compete? Was it remote or was it in
It was
person?
locally. It was like a little meet that was held at a powerlifting gym. It was actually pretty interesting. It was pretty cool experience. It was my first one.
Cool. Well, congratulations. That's very cool.
Thank you.
Cameron Galt.
I guess I can do a standing backflip.
That's very cool. Wow. Okay. How did you learn how to do that?
I did competitive gymnastics through high school.
Cool. You and Katrina were both gymnasts. Is that right? That's awesome. Do you know each other? Well, you have a lot in common, it seems like. Okay, Derek Garcia.
I guess something interesting about me is that I'm like a dancer, so I like learn choreography and all that, like hip hop, all that.
Cool. That's awesome. So anyway, I'll show it to you for our break one day, but there's this great video to Rolex. Anyway, I'll show it to you. I'll show it to you maybe this week. That's a great idea. Cool. Well, you have to send me a video of your troop or whatever. Kimberly Gonzalez Lopez.
I would have to say that mine is I used to live like all kinds of different states. I would live in Florida, Alabama, Wisconsin, Seattle. I would live everywhere.
Wow, that's crazy. Why were you moving so often?
Because my dad was a contractor, I think.
He was
Oh, no, he was
building.
a construction worker.
Yep.
So
He was
he would like,
building.
yeah, we would move like every 3 months. So we were just all over the place.
That's crazy. That's awesome. So I have a project where, anyway, I'm trying to think if this is, did he work for a given company or was he just going to where he heard there was a lot of building? How would he move?
I think he would just go where there was a lot of building.
Okay, cool. That's awesome. It's a real American there, moving for work. Esmeralda Hernandez de la Torre.
For me, I guess it would be that I'm a childhood cancer survivor. When I
Oh
was
my
little,
gosh.
I had leukemia. I had it for like 2 years and eventually everything went good. So yeah, I'm
That's
grateful for that.
awesome.
Yeah.
Yeah, that's amazing. My wife is a nurse practitioner and she works with childhood cancer. That's her specialty. So she's seen probably hundreds of kids that were exactly where you were. So that's amazing. That's awesome. Denelson, Pack Store. Noah Ibarra Perez.
Good morning.
Good morning. What's the most interesting thing about you?
The most interesting thing about myself.
Yes.
I guess I've drowned like about 7 times.
You've drowned 7 times?
Close to drowning, yeah.
Oh my gosh, we have to keep you away from
I
water.
mean, I learned how to swim, but yeah, I guess that's one thing.
Okay, so what does it
Never too
you,
late to learn just how to swim, that's all.
you never did?
I learned eventually.
Oh, you eventually, so this is not a risk any longer. Is that what you're telling me?
As of a year ago, no.
Okay, you learned to swim a year ago. Okay. Oh my gosh. There was another, were you the one that told me that you wanted to learn how to swim? Or was it someone else?
I think that was probably someone else.
Okay. Because that's like a lot of you don't know how to swim. That's not good. We got to teach you how to swim. My kids, yeah, we have to keep them away from water because they kind of know how to swim, but I don't, their kids are the leading cause of death for children is actually accidental drowning. It's very deadly. Well, that's pretty interesting. We got to keep you away from the water, Noah. Kimberly Lopez Alvarez. I like your cat.
Morning.
Hey.
Cat? What? Oh, I don't know if this is the most interesting thing about me, but I just think it's kind of a difficult thing. But like, I'm not really good at like working for people, so I've like had jobs before and I just didn't enjoy it, and so I think it's opened a lot of opportunities for me. So that's something that's unique about me.
What kind of opportunities did it open up for you?
Well, I live in a rural area, just like Merced, so there's not a lot of like great opportunities for like a college student. There's like working at a fast food place or something like that, right? So I like started my tutoring business, and I've started since living here, I moved here in the summer. I've started 2 businesses, and I think it's a really good experience. And
Oh, that's awesome. That's great. Saul Lopez.
I would say that the most interesting thing about me is that I have a lot of interest. I'm always everywhere. So it makes me, it just puts me everywhere.
What are some of your interests?
I like everything, man. I like music. I like food. I like clothes. I like, just everything. I'm always everywhere.
Okay, very cool. Stephanie Martinez.
I'm not sure if it's interesting enough, but I'm left-handed.
Oh, that's kind of cool. A huge fraction of geniuses are left-handed, which is interesting. So we maybe we know who to ask our questions to. Warren Quijano.
Most interesting about me, interested thing about me is that I used to sing and play guitar.
Cool. You used to. That's the saddest.
I stopped. Now I'm into lifting like Abraham. I'm a bodybuilder though, not a power lifter.
Cool. That's great. We'll have to have you sing for the class sometime.
There's no way.
Oscar Sanchez Fernandez. Manuel Sarabia. Neb Tesfaye.
I have a lot of things that are interesting about me, but I like this one the most. I used to own a pet monkey.
Oh, cool. In the United States, you did?
No, in Ethiopia.
In Ethiopia. Cool. What kind of monkey was it? Capuchin?
No, it was a chimpanzee.
Chimpanzee? Were they nice?
Yeah. He was very rowdy.
Yeah.
Yeah.
And they can be really savage. Like when they fight each other, they rip each other apart, like literally their limbs from their limbs.
Yeah, I mean, I had it, but I couldn't. My mother didn't let me near it. Very bad.
Okay. Yeah, they're super strong and they're very dangerous. That's really cool though. In Ethiopia, you grew up. You must have moved before puberty.
Yeah, I moved when I was 8 years old.
Okay, yeah, that's great. They find that you can never quite get the accent down if you move after puberty, if you start learning a language after puberty.
Yeah, I had a friend that moved here when he was about 13, 14, and he has an accent.
Yeah. Leana Tran.
Hi. So I'm not really sure if this is interesting, but I really into novels, like Chinese novels and all that. So since November last year, I have been collecting them. It's in like Vietnamese since I'm bilingual, so I can read them. And I think I have been buying them, and I think it's more than 200 books or more. Yeah, I'm
That's
not sure.
incredible.
Yeah, they are
That's
pretty
awesome.
addictive.
That's great. I'll have to email. I have a children's book I wrote, and I've been just trying to work on. It's not very good, and it's a short book, but I'm like, oh, I wish I could get better at that. So that's very cool. That's awesome that you're reading. I think that's a great pastime. Devin Villarreal.
Hello. I think the most interesting thing about me is that I have a bald spot. You can't see it now because I have hair, but I cracked my skull at one point when I was young, so I have a bald spot there.
Gotcha. From a scar. The scar tissue doesn't. Yeah, gotcha. Very cool. Well, how did you break your skull?
I was dancing with my sister. I was hella young, and then she flung me, and then I had these like old rocking chairs, so I hit a nut of it, and then it was just cracked.
Oh, sorry. Did you say you were hella young?
Yeah, I was like 5'4".
Okay, hella young is 5 or 4. Good to know. Very cool. It's great to get to know all of you a little bit. So I wanted to ask you guys a question. So I uploaded the last 2 lectures, and for 78% of the space on Canvas is filled up with the lectures mostly. So here are my options. I went to Kaltura, and I couldn't figure out how to upload it. I don't think I have. Have your other professors had accounts through UC Merced for Kaltura? Yes. Do you know? Have any of you done it before? Maybe I should just email Lee, Jason Lee.
Ask the Econ 100 teacher.
Okay.
I think he uses the Kaltura media gallery.
Okay, Kaltura is linked
There's
to.
also an option to just record right on Zoom and have like a Zoom tab for the class. And when we click on Zoom, oh yeah, we have a Zoom tab. And when we click on Zoom, we could click on previous meetings and those stay forever, basically.
Oh, cool. So I need to have a Zoom tab? Is that what you said? Zoom tab.
Yeah. So for Econ 100, we have a Zoom tab, and then there's he doesn't record them on Zoom. He records them elsewhere, like on something else. But if we click on previous meetings, we can click on that meeting and it stays until the end of the course.
Okay. Let me try it. So the other idea I had is I could post these to YouTube, but then your faces and some of your comments would be posted on YouTube. So if I did that, I would have to get all of your permission. Do you guys feel good about that or bad about that? That would be something I could start today after class, but I don't want to do that if people feel uncomfortable. Feel good. So what I'd have to do is I'd have to get I guess, I don't know what I have to, but after class, I'm going to talk to Jason and find out what he does. And, but yeah, we can do that too. Okay. That's great. I graded your homework over the weekend. They looked very good. And the key to the last one was that there was a lot of sort of good ideas on that last one. The kind of the key was that you wanted to somehow get a universal list of the residents of LA and then randomly sample from those residents. So some people said I would get a list from the DMV. I would take a list of all the addresses. I would get a, something like I would go to the IRS and get everyone's contact information that had filed for taxes. So those are all great. And then you would randomly sample. So some of the ones that were close, but not quite right. So one of them was I would find out who earned, below 10,000. I'd find out who earned above 100,000, and then I'd take a random sample of each of those. But actually, this doesn't quite answer the question, because what we need to know is how common each of those groups are. So you need a random sample of the whole residential pool, not a random sample within each group, within each income group, for instance. I put little comments in on your homework so that you can, if you didn't, the lowest score for people that finished the homework was 94%. So no one got less than an A if they had finished the homework, but I gave you a little comment if it wasn't quite, if you didn't stick the landing exactly, but you were close. I just kind of explained where the key kind of feature is that we were missing. Okay, and then the last thing I'm going to do before we get into the lecture is go on and show you a cool paper about minimum wages. So I was trying to find the effect of marijuana on productivity, and I have had a hard time finding that, but I will ask a friend. So this is kind of a cool paper though. These guys, so let me just go to the very front. So the main question here is, how do minimum wages affect employment and earnings? And the reason that that's hard is that different states are implementing minimum wage laws at different times. So California has a really high minimum wage, in part because wages here are already very high. So if you're living in San Francisco and you're a barista, there's a lot of wealthy people, and you're able to earn $15 an hour. If you live in Tulsa, Oklahoma, people just don't pay $15 an hour. So a $15 an hour minimum wage in San Francisco will be quite different than it would be if it were in a rural part of the country. So that's part of the struggle with minimum wages, that they apply to everyone. If you apply them broadly, they can really hurt rural areas in particular. So this is just a little figure that will soothe and you, because it will be so comfortable. But so basically, as wages go up, the demand for employment goes down. So that's just a key feature. But also, as wages go up, more and more people want to work at the minimum wage. That's where, and then supply and demand, they cross, and you get A. When you have a minimum wage, you're basically saying you have to pay at least that red line. And so what that does is it makes it so that employers want to hire fewer workers, but more workers want to work at that wage. So it makes this gap between, so the new employment level is B, and so all those people who would like to work that aren't, for whom there aren't jobs, or become unemployed. So that's kind of the main question about the minimum wage is what is the trade-off associated with the minimum wage. So this is a really cool, interesting, rather, policy that happens in Denmark. When you turn 18, the minimum wage goes up. So the minimum wage for a 17-year-old is, I can't remember what it is, but something less than what it is when you're 18. So this is just your hourly wages jump when you turn 18. So the x-axis here is how many months we see your wages relative to your birthday. So you see, oh, this guy right here, this dot is what's the average wage. I'm sorry, I don't have my pen on. Actually, I'll come to that in a second. But basically, on your average birthday, the wages among people that are employed go up by about 30%. So that's a big increase in average wages. And you can just see it's such a clean kind of line. So this is employment. So what you see is wages go up at age 18, but employment goes down by about 30%. So there's this trade-off between higher wages and then lower employment. So employers are obviously not willing to hire as many people at a higher wage. They will scale back how many people they employ at a higher wage. So that's really interesting. And then among the people that do have jobs, they get fewer hours. So that's what this is, that the hours, there's a cut in hours when, even if you keep your job. So if you think about what a minimum wage does, is it makes it better for people that are able to keep their jobs, and it makes it worse for people, obviously, that lose their jobs because of the minimum wage. That's just kind of a classic trade-off. So what they do is they just calculate what's the total income around the birthday, considering the fact that they're paid more per hour, but they receive fewer hours, and they're less likely to be working. And what you find is actually the minimum wage reduces what they're paid by, basically it just doesn't actually have an impact on incomes at all, even though some people are being paid more. So in this example, minimum wages are actually increasing inequality by raising wages for some people and increasing unemployment for other people, and they're not having any net impact on earnings. So people aren't actually earning any more money. So that is a really great, this is a great paper by the guy I know is at university. I think he's at London School of Economics. So that's a nice paper. Okay, any questions about that? Let me see chat. I can't see your faces when I'm sharing a screen. Okay. Okay. Thank you, Kimberly. Okay. So the bad news today is that I left my stylus in Idaho, so I can't write very well. I can highlight stuff, but I can't write numbers super well. So that's my bad. I'm going to go to Target after class, I guess, today and try to get a new stylus. But let's just review what we learned yesterday, and then we'll hopefully get into the homework. So we've got distributions. These are distributions, and a distribution is just basically how are data spread out in a particular variable. So remember, this is how are people's heights spread out, and here is how are the rolls of a dice spread out. This is a uniform distribution because every column's height is the same. This is a normal distribution because it's a bell curve where the mean is very close to the median and the mode, and normal distributions occur very commonly in nature. So we kind of we see these a lot. We've got basically when we have a single variable, we're usually interested in understanding it in terms of two kinds of statistics. One kind of statistics is what is the middle, what's the most kind of, the middle or the most typical value in this, of this variable. So that would be the mean, the median, and the mode. And they're all slightly different. The mean is just the average. You add up all the values in the data set and then divide by the number of values to get the average. The median is the middlemost value. You get that by sorting the values from smallest to greatest or greatest to smallest, and then taking the middle value, that's the median. And the mode is the value that's the most common in the data set. Which value is the most common in the data set? We went into stata, we played a little bit with stata. And then I think actually that's where we stopped. So today we're going to talk about the second way in which we describe data, and that's in the measures of spread. So you can imagine you can have a variable that's very concentrated. Most people have very similar values in the data set. You can imagine other data sets where people are really spread out. So imagine looking at the income distribution in a particular neighborhood. So in this particular neighborhood, people are buying home and owning homes that have similar values. So if you looked at the income within a small neighborhood, you might find that actually people within that neighborhood have very similar incomes to one another, so that there's not a lot of spread in the incomes that you see there. If you look in a whole city with many different neighborhoods, you might find that incomes are much more spread out. There will be people who have very high incomes, people that have very low incomes, and lots of people in the middle usually. So the way that we measure spread is we typically take, we calculate the mean in the data. That's what this is right here, a mean. And then we find the distance between each data point and the mean. We square it, and then we sum all of those up. So the easiest way, and I'll do this really quick. So this is for the population, is this one up here. So this is the population. And if we don't have a population, but instead we have a sample, we do something that's slightly different, which is important to know, which is we calculate the variance in the sample this way. And the main difference is that instead of using n to divide it by, we're going to use n minus 1 if it's a sample. And I'll explain why that is in a minute. It's called the Bessel correction. And all we're going to do is first we calculate the mean of the variable in the data set. That's where we get x bar. X bar is the mean. And then we calculate the distance between each data point in the data set and the mean, and square each of those, sum them up, and divide by n minus 1. So let me just give you a little example. Let me see if I can. Let me do one right here. So remember, I don't have a pen. So say we have a data set of just 2 people. We're going to make it really simple. 1, 2. And here we have another data set of, we're going to try 2 different things. 1 and 2, and we have a data set of 1 and 10. Okay. So this could be how many times have you been married, or something like that. We ask 2 people, 2 of our friends we ask, and in one of the data sets we get that one friend was married once and one friend was married twice. So how would we calculate the variance? We'd calculate the mean. So I'm going to calculate the mean like this. X bar is equal to 1.5. The distance between these 2 points, the first point will be 0.5 away from 1.5, and the second will also actually be 0.5 away from 1.5. So to find the variance, we're going to say 1 over 2 minus 1 of the sum of 0.5 squared plus 0.5 squared. So 0.5 squared is 0.25. So that will be, there's 0.5 divided by 1. So we're going to get that the variance is just 0.5. So what does that mean? It just means it actually doesn't mean very much without a comparison. So let's do it again for our data set of 1 and 10. What's the average here? Actually, I'm going to make it 0 and 10 because it will just make the math a lot easier. So the mean in this data set is going to be 5. And so we're going to have 1 divided by 2 minus 1 sum. So 0 is 5 away from 5 squared, and 10 is 5 away from 5. So we've got 5 squared is 25 and 5 squared is 25. So we're going to get, we're going to have 50. Okay, so that will be the variance. So the variance here is 0.5 and the variance here is 50. So what does that mean? It just means that that the data points are a lot more spread out in this second data set than in this first data set. In the first, the data points are close together. In the second, the data points are far apart. That's all spread means, is how spread apart, how far apart are the data. Does that make sense? Can I stop there for questions? Let me just stop.
Professor,
Yes.
for the sample variance, when it goes 1/2 - 1, why wouldn't it be 1/10 - 0? Do we still use the 1/2 - 1 from the population variance over to the sample?
So
Does that
you're
carry over?
say that one more time. Did you say why don't we use 1/10?
The when we started off the 1/2 - 1,
Uh-huh.
we use that in the population variance. Does that carry over to the sample variance, or?
So I'm sorry, I just didn't have enough room to write them both in the sample area. These are both sample variances because they're from a small sample rather than the whole population.
I see.
So whenever we use so I'm just counting how many people are in the data set, 1, 2, in either case, and we're using the sample variance formula in both examples because they're both samples. Neither of them are populations. I know that that's confusing because I wrote that in the population variance area. That's just a constraint of the slide deck that I made. Very good question, though. Thank you for clarifying that. That would be really be confusing. Yeah. Derek, Levi, Esmeralda, Leana, Yesenia, questions? Hey, all of you, put your cameras off, you munchkins. Every single one of you. Okay. No questions. Manuel, Kimberly, Cameron, any questions? Saul. Okay. Stephanie, Ned. Okay. So let me share the screen again. Okay. Yeah. Thank you, Ibrahim, for clarifying that. That's very helpful. Do one. Sorry, my wife is going to find a stylus. She's at Costco. Okay. So here's just another example. I will be bad at the math, but all we're going to do to calculate the variance is first, we calculate the mean. How do we calculate the mean? We just add up the values from the data set right here and divide by the number of values that there are in the data set. That's going to give us 7. And then all we do is follow this formula that we have for the sample variance. We're going to take each of the values in wages and subtract from them 7. So we got 5 minus 7, 6 minus 7, 8 minus 7, 9 minus 7. So this will be 2, a -2, -1, 1, and 2. We're going to square each of those. So the square of -2 is 4. The square of -1 is 1. The square of 1 is 1. The square of 2 is 4. So we're going to add those up. That will get us 10. 4 plus 1 plus 1 plus 4 is 10, and divide by 3. And that will give us the variance is 3.33. 33333. So that's just how we do the variance. So one great thing about this class is it's often going to be, there's a formula right here that you can use to do the whole thing. So as long as you can remember the formula and just be careful in the math, there's a lot of it's just kind of understanding that there are formulas for doing this. And the other part is kind of getting the intuition of it. So what we're really doing is calculating the distance between each of the each of the data points and the mean. So that what a variance really is how spread out are the data from the mean. Okay. That's what a variance is measuring. Okay, so the standard deviation and the variance are actually not very different. So for basically all the standard deviation is the square root of the variance. So if I asked you to do to calculate the variance and the standard deviation, you would kind of be lucky because all you have to do is calculate the variance and then take the the square root. So the sample standard deviation is just the square root of the variance. So it's the exact same formula plus a square root. So in our previous example, you would have been able to find that the variance is 3.33. And then if I asked you, well, what's the standard deviation? You would just take the square root of it and you get 1.82. Okay. So now we got to talk just for a couple minutes about a really important feature of the sample variance and standard deviation that is a little bit, I think it can be intuitive, but I've found that it's just hard for students to grasp. So if you can just kind of focus your attention for a minute, this will be really worth it, I think. So notice that when we're finding the variance or the standard deviation of a variable, we divide not by n, but we divide by n minus 1. So this is called a Bessel correction, which is dividing by n minus 1 rather than n. And the reason that we do it is that when we are using a sample mean to calculate the distance between each data point and the mean, the sample mean is artificially close to the data points in small samples. And I'll show you an example of that. Oh boy. I guess you saw that because it's on, my son just threw my wife's phone at Costco and broke the screen, so that's good. Okay, so what that means is that because we're calculating the mean from a small sample, each of the data points is going to be artificially close to the sample mean. So what we do is we divide by a smaller number to make sure that the variance is conservative. Dividing by a large number makes the variance larger. No, dividing by a larger number makes the variance, no. Dividing by a smaller number makes the variance larger. That's why we're doing minus 1. So for large samples, there's no practical difference between dividing by 1,000, 10,000 and dividing by 10,001. Those are going to give you the same thing. It really only makes a difference for small samples like 4 or 5 or 10. And the importance of the Bessel correction just kind of shrinks as we get into larger data sets. And really, like when you have a job, you almost will never want to use a data set with fewer than like 100 observations. So a data set with fewer than 100 observations is kind of not that. I mean, I guess there are places where you would need to use fewer than 100 observations, but just you can't learn very much from those because they're so small. It's very hard to get good statistical properties, good statistical information from very small samples. So let me give you a little example. Say that the for the Bessel correction. So say that the population was 0 through 10. So the population is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. And the population mean is 5. And we can calculate the population variance will be 10. If we do all that math, that's what we'll find. What if we had a sample size of 2 where we randomly drew 2 values from this larger data set of the population of 11 draws? What we might draw is we might draw 6 and 10, okay? The mean of 6 and 10 will be 8. And when we calculate the variance using the true mean, we will get something 13, which is pretty close to 10. It's relatively close to 10. If we use the sample mean of 8, we'll actually find a variance that's much too small. So the sample mean variance, if we didn't use the Bessel correction, would be 4. So this would be less than half of the true variance. And why is that? It's because we're calculating a mean from a selected data set. So the mean is artificially close to each of those data points in our sample. So when we use Bessel's correction, however, instead of dividing by 2, we'll be dividing by 1. That's where this comes from. And we get 8 instead of that. So you can just notice that 8 is a lot closer to the true variance of 10 than 4. And the idea is just that when the mean is calculated from a very small sample, the mean is going to be very close to the mean is going to be very close to the average. The mean is going to be very close to each of the data points. So here's a good example. Say you had one draw. Say we only drew one number from the population and was 6 or 10 or 0. It doesn't matter because each of those, when we calculate the sample variance, it will be 0 away from the mean that's calculated based on it alone. That kind of gives you a good example. It's like as the sample gets smaller and smaller, the mean is more and more like each of the values that you pulled. Let me stop and take questions here because this is an important kind of this is an important concept. Okay. No questions, no questions. Okay. Devin, Esmeralda, Ibrahim, Katrina, Kimberly, Leana, Manuel, Noah, Saul, Stephanie.
Can you just slightly repeat the difference between the means?
The difference between the means? Yeah, so yeah, the mean up here, let me share this again. The means from the population and from the sample.
Oh, okay.
Is that but that's what you're asking, I think.
I think that's probably what I was misunderstanding.
Okay. Cool. So say that first we had a population. So say we had, let me try to make a good example. So say I had a deck of cards, small deck of cards, and it had values from 0 to 10. So we call that the population because that's actually what we're interested in, is this funny deck of cards.
Mm-hmm.
Say we pulled a sample from that population. So I randomly drew 2 cards and I got a 6 and a 10. The true population average is going to be 5, but the sample average will be 8 because I have drawn unrepresentative values from the deck. So what that means is that because I've drawn unrepresentative values, the mean is going to be very close to each of the other values that I drew for the sample.
So the sample mean is just a random number.
The sample mean is a random. Yeah, I see what you're saying. Yeah, so sample mean isn't going to be very stable. If I drew 2 different cards, we get a different mean.
Okay.
And whenever we drew 2 cards and calculate the mean, we would find that mean would normally be closer to our sample than the true mean of the data.
Okay.
So the true mean of the data is 5, and we're going to tend to get means that are not 5 in a small sample, and our samples will tend to be closer to those false means.
Okay. Makes sense.
So this is a tricky one, and it's worth coming back to these couple slides and just doing some review on it. It's a really important piece. And I can try to find another way to say it too. But sometimes I just said something funny and one of you can say, oh, that doesn't make sense because you said blah, blah, blah. And that happens. Stephanie Martinez, Warren Kahano. Any questions? Yesenia, Neb. No questions, awesome. Okay. Okay, so let's do this one in groups. Let's see here. No question, no question, no question. I didn't get a chance to write it down. Can I see the formula again? Yeah, sure. Oh, the formula for which thing? Is it the formula for the standard deviation?
Yeah, professor is good. I got it.
Okay, awesome. Sorry about that.
Thank you. It's good.
Okay, so let's do these together. I'm gonna break you out into two groups, in part because I'm not sure. I want the groups to be small enough that you can talk, but big enough that that you're not alone. So I'm gonna assign. Maybe I'll do 3 groups. Okay. So you might need to take a screenshot of this to see it when you get to see it when you're in the break room, in the breakout room. So would you guys just take a screenshot of that? And then I will break you out. 1, 2.
Right? Hello?
Anybody here? Leon?
Yeah, I believe so. I think it is 7 and 7. And then the greater mean.
You guys should all put your cameras on. Noah, Saul, Ibrahim. I think you guys can talk better if you have your cameras on.
And I think the bottom sample.
Okay, you guys need to put your cameras on. You're working together. I think it's much easier to work together if you can see each other. Are you guys there?
Yes.
Are you guys just working on it? Working through the example? Are you guys working? Hey, all your cameras are off. How are you supposed to work together? You can't even see each other. Stephanie, Esmeralda, Kimberly, Stephanie too.
Professor, do you want us to round the mean? Because the one for y has a funny decimal to it, and I don't know for the variance if you want us to round it up.
I would just round it to the nearest whole number or something like that, just for simplicity.
All right.
Okay. Okay, let me ask a couple questions. Was that helpful? I felt like they were kind of quiet. Or do you guys find? I mean, it could have been that you were all working on it individually and then comparing. Was that helpful, or would you rather do it all together in a bigger group? Can I just get some chat? Are the smaller groups not helpful? All together, I thought it was good. All together, do it all together, all together. Okay, all together is better. We can do it all together in the future. Okay. Oops, I lost my. Okay. Oh boy. Okay, so what is the, just a sec. Okay, so what are the ends for each of these two samples? What do you get for the X sample?
Is it 7?
Yep, that sounds right. And X is equal to 7, and Y is equal to, what's the N of Y? Do you guys know?
7.
Yep, 7. Okay, good job. What is X bar? What is the mean of X?
6.
6. What's the mean of Y? Good job.
5.3.
Can anyone get something different on either of these? I haven't done them, so I don't know. I haven't done them for a bit.
I rounded to the nearest 10th. Is that cool? It was like 5.285 something.
Okay, 5.285, that's great. Which sample, so which has the greater mean?
X.
X. Which has and then what are the variances here? So we have, I would usually go, let's see, S squared of X. What's the variance of X?
2.
2. And what is the variance of Y?
It was like 13.3.
13.3. Is that what most you get? Something like that? 13, yep, 13.23 or something like that. That's great. Okay. So the variance is greater in Y, but the mean is greater in X. So you can kind of get a little bit of an idea of that by looking at the data series here. So here you get lots of 6s and 5s, kind of all the data close together. Here you get the data set. The data are obviously far apart. You get 10s and 1s and 9s and 2s. So the data are much more spread out. Okay. So let's do, we'll do.
Professor?
Yeah, go ahead.
For the variance, I was trying to look at the example you gave us and kind of compare it, kind of walk myself through it. So I noticed in the example, like, how do you get the fraction that you multiply the numbers by? You know, like when you square everything, you subtract it from what? How do you get the fraction that you multiply it by?
Oh, great question. So the fraction you multiply it by is the is 1 over the sample, which here we had was 7 minus 1.
Oh,
so you're multiplying it by 1 over 6 in our example. Does that make sense?
Yeah.
And normally you just like in a mean, you would do 1/7. In the when you're doing variance and standard deviation, you do 1/7 minus 1 or 1/6, because what we're doing in the standard deviation is we're comparing the data to the mean, and the mean is a little bit goofy in a small sample.
Mhm.
Okay.
Yeah, thank you very much.
Yeah. Okay, so the graph below shows a normal distribution with a mean of 5 and a standard deviation of 3. So, just the interesting thing about normal distributions is that this is just like a feature of normal distributions, is that 68% of people or the sample will be within 1 standard deviation of the mean. So 68% are right there in this little kind of area between 2 and 8. So, to find the bottom and the top of that, you're just starting with the mean of 5, and you're subtracting 3 to get the lower bound of that band, and then to get the higher bound, you're taking the mean 5 and adding 3 to get 8. So the standard deviation is 3. What is the variance of this distribution?
Is it 2?
The variance is not 2. A good get, very good guess. What else? Anyone have another idea?
Is it 9?
It's 9. Yes, exactly, Esmeralda. Thank you. So remember that the variance is the square of the standard deviation, which is the same as saying the standard deviation is the square root of the variance. Okay. Questions there? So this is how it's very nice to plot data. So this is a place in which we've plotted 2 distributions. The blue, a distribution of blue and a distribution of red. So which distribution has the higher mean? The blue or the red? The red, that's right. The red has a higher distribution, a higher average. So in a normal distribution, the tallest point is always the mode. In any distribution, the tallest point is always the mode. But in a normal distribution, the tallest point is also the mean, the median, and the mode. So we know that the mean is higher in this red one. You might have been tempted to say that the mean is higher in the blue one because it's taller. What does height represent in a probability figure like this? Cameron, Devin, Derek. Katrina, Kimberly, Levi, Luis, Leanna. What is height in a figure of like this?
It's the mean.
It's not the mean here,
The
so,
mean.
but I think you're on the right track.
Is it how often that score or that number will occur?
Exactly. So it's the likelihood of seeing a particular score, a certain value. So this is exactly a very good distinction to know. So you might have thought that the blue line has the higher mean. It doesn't have the higher mean. The mean is what we see down. Sorry, why won't this move? The mean, let me tidy up a little bit. So you might have thought, oh, look, this is so tall. That has to be the have the higher mean. But the mean is actually what value is under the peak. So the mean for the blue is like 0, and the mean for the red is 5. Okay. Instead, the height is how common it is to see a particular value. So the blue one has a much more common value, which is 0, is very common in the blue curve. But even the average value in the red curve is relatively smaller. You only see it about 12 or 13% of the time. Okay, so that's a really important distinction, is the height is not the mean. Where it is on the x-axis is where the mean is. The height is how likely we are to see a particular value. Okay, so which distribution, the blue or the red, has a higher variance? The red. Okay, and all we're thinking about when we talk about variance is which one is more spread out. I'm going to try to make two lines that are pretty close together. You can just see that the red one is fanned out more. Its highest and its lowest values are further apart. And also, if a distribution is shorter, it tends to be more spread out. A tall distribution tends to be a very highly concentrated one with a low variance. And a short one tends to have a higher variance. Okay. So let's take a minor break and we'll start on the homework. Let me just show you a video, a funny video. Okay, if you don't mind a little bit of anti-male sexism, this is funny. It's also true stories, so.
People ask me every day, what do I do to look the way that I do? When I tell them it.
No one knows.
What happened? In our area of the country, as you know, when someone we know gets sick or has passed, that's the way we do it. Have you noticed it? If we hear the word passed, and then we go on. I was seated next to a woman on the airplane, and not a month or two ago, she was 70 and going to see her sister. I'd never met her. And I said to her, how many siblings do you have? She said, I have 2 sisters, and then we had a third one. She passed in 1941, and both of us went, oh, I'm so sorry. You know what I think it is? I think it's just a little show of respect, just to stop for a minute and do like this and do this. Well, in our area of the country, when somebody gets sick that we know or has passed, we take over food. Have you noticed it? We take over food. You can buy that food. You can go to the deli and the grocery store, get something great, hire somebody to bake it, but put it down in the big list of important things for life. You get a lot more credit if you make it yourself. You can put it on your grandmother's platter, but the women in the kitchen will say, I know where she got that chicken. I'm telling you, it works out that way. And I make only one thing, and that is small little 7-Up pound cakes. I make them by the dozen. I'm out of town, something happens, left brain takes it over. And not.
So I should just say she calls her husband left brain, which is a joke about how men think, that they're very kind of linear and literal. That's a.
Long ago, got up one morning and heard that a friend of ours was sick and went to my freezer and my pound cakes were depleted. I did not realize I was out. He said, I've been taking them to a lot of people been sick. I said, well, I didn't know they were gone. I got to get a pound cake made before I leave town. Honey, go to the grocery store and get my ingredients. He said, I'm trying to get to badminton. I said, well, it's just a few ingredients. He said, I tell you what, I can get there and get it and still get to badminton, but you make sure I can go through that express lane. No problem. We don't go to the grocery store together anymore because I frankly don't care what things cost by the half ounce. So I made up the list and he left. Well, y'all, I waited. He didn't come back. I thought, he's gone on to badminton. And I thought, no, where could he be? I was getting ready to call the grocery store and I heard the car pull in. He came huffing up the steps, had 2 sacks and more sacks hanging on his arms. He just glared at me, started putting stuff down, and said, I'll get some more out of the car. I looked in the first sack, there was a pound of margarine and 2 gigantic bottles of vanilla flavoring, doling out a half teaspoon a time. It would take forever to get rid of these 2 gigantic bottles of vanilla flavor. And in the next sack were 3 dozen eggs. I said, they had a special. I'll tell you, they have had a special. I didn't need but 5 eggs, and I just said a dozen. In the next sack was a big old thing of shortening, 2 of them. And in the next sack, 2 more, 12 pounds of lard. We could fry fish for everybody in here. But in that 4th sack, I found my list. And I'd like to step out of the kitchen just a minute to tell you something. Left Brain is a smart man. He went to Duke University on a basketball scholarship, played basketball for 4 years, and graduated in the same 4 years. Then he went to Carolina and got a master's degree and a doctorate. He has over-degreed himself. But I don't care how many pieces of paper you frame and put on the wall, if you have a left brain, it's going to kick in on you. And it kicked in on him about the 3rd aisle of that grocery store. I'll step back in the kitchen. I found my list, and in my eagerness to make sure that he could get through the express lane, for probably the first time in my life, I numbered the items. Number 1, a pound of butter, no problem. Number 2, large bottle of vanilla flavoring. I had 2 of them. Number 3, a dozen eggs. This man has a doctorate degree. Number 4, a big tub thing of lard. I could hear him coming back. I looked down at number 5. Said a 5-pound bag of sugar. I knew he was coming in with 25 pounds of sugar. And number 6 was a 5-pound bag of all-purpose flour, 30 pounds of flour. Now, I believe in accepting things you can't change, but I also believe in hounding things sometime, and then sometime I let it ride. And this time, y'all would have been proud of me. I let it ride. I put that list behind my back. He came in again, plopping down sugar and flour all over, bam, 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 gets it all down there and says, 1 more trip. I went back to my list and looked, and number 7 was a bottle of 7-Up. I don't want that big bottle because if you're gonna make 1 cake and you just use it, it'll be stale by the time I get back. I told him I wanted a 6-pack of those medium-sized ones hanging. So I knew he was coming back in with 42 bottles of 7-Up. And in a minute, there he was. I had just cleared a space for him right here, back it up. Put them all down and turned around to me before he left and said, well, obviously, they wouldn't let me through the express lane. But you know what? He got all the way out in the hall and came back and he said, for the record, I figured out what I had done. But by then she was ringing up the 7-Up. And all these people behind me in line were laughing. And I got to get to badminton. Don't tell anybody. I said, I won't. 3 days later, I went to the grocery store And a woman that was checking me out says, I think I checked out your husband a few days ago. I said, I'm sure you could have. She said, that was an interesting order. I said, let me explain to you. And she was from this area too, and this proves it, because I said, anytime a friend of ours gets sick or has passed, and both of us went, said, I make pound cakes and we take it over. This woman said to me, is there an epidemic?
Anyway. Okay. Break time. So let's get started on the first homework. Or I guess this is the second homework, but it's called the first homework, assignment 1. So what we've got is we've got a little data set, a little tiny data set of 6 observations. And we have wages and experience and training. And let's just read also the data below show the hourly wages earned by 6 employees. And then we've got number of years of work and a binary variable indicating whether or not the employee has completed a training program. Okay. So we have to set up the expressions. We have to show the formulas that we're using, but we can use a calculator to do the actual math work. So the first part is, what is the mean, variance, and standard deviation of the wage? So first we're going to write out what is the mean. The mean of the wage, we can write it W bar is going to be 1/6, or we'll just write the formula 1/n. And notice we don't do Bessel correction on a mean. Okay, 1/n times the sum of the WIs. Okay, so we're summing up all the wages and we're dividing by n, dividing by 6. So that's the wage, the average wage. What is the variance of the wage?
I got like 13.3.
Oh, you've already done the variance, or is this the average?
Oh, this was the mean, sorry.
Oh yeah, what did you get? 13.3?
Yeah.
Okay, awesome. That's great. So, and then thank you for doing that. I appreciate it. And then for the variance of the wage, we're doing something similar. We're going to multiply the whole thing by 1/n minus 1. And we're going to take the sum of each of the wages that we see minus the average wage, which we think is 13.3. And then we're going to square each of those. And that's going to give us the variance of the wage. And then the standard deviation of the wage is going to be something like this. Standard, oops. Is going to be the square root of whatever we get up here. So we'll just be able to plug in the variance that we calculate and take the square root of it, and that will give us the standard deviation of the wage. So has anyone calculated the variance? Okay, so we can, I just don't have my pen. I'm using my middle finger to write, so it's just very hard to write a lot of little numbers, but we can, let me work on this a little bit. can I do? Here we go. Okay, yeah, I get, for the average, I get 13.33. Um, okay. Has anyone else done the variance? I have a number that seems big.
I got 18.668.
Okay,
I just rounded it to 18.7.
Okay, that's great. So that's what I get too. Let me do this real quick. Do it another way really quick. Make sure I get the right stuff. Yeah, so we get 18.66. 18.6 repeating. Okay. So then when we try to go get the standard deviation, all we have to do is take the square root of the variance. So that's nice. That makes our life simple and happy. Let's see your square root. And I get something like 4 equals 4.32. Oh, blah, blah, blah. Okay. So we have the mean, the variance, and we have the standard deviation. Any questions calculating those three? Okay. No questions. You guys are good. Okay, let's do this. Let's do the same for B. What are, I'm going to just delete all this, but it's going to actually be basically, a lot of it will be the same. So instead of 13.3, it'll be a different mean, but let's go up and see what is it. So what is the mean variance standard deviation of experience? Yeah, I get 4.32, but it could just be that we're rounding slightly differently. That we're rounding the mean differently, or rounding this something differently. But yeah, Yesenia, you're right on track. Okay. So when we're doing the experience, we're going to do the exact same thing. Let's see what we get here. 1, 2, 3, 4, 6. So I get a mean. All we're doing is adding up all the values in the experience column and then dividing by 6. And I get something like 4.5. So then we can put 4.5 as the average when we're calculating the variance. We're going to take the difference between each of each of the okay, so we're gonna sum up and then square the difference between each variable and the mean, 4.5. I have something like 10.3. Does anyone get something like 10.3? Anyone get 10.3? And then to get the standard deviation, all we're gonna do is take the square root of the variance, and we're gonna have something like 3.209. Okay, so that's the standard deviation. Questions on any of that? Okay, so let's do this letter C. Letter C. Letter C is probably just a fun thing to do. So let me put these together. So draw a scatter plot with experience on the horizontal axis and wages on the vertical. So this is how we do that. So we're going to have so I'm just going to do this, with my finger and on this bad tablet thing. But if you have a ruler or some graph paper, it would turn out a lot clearer, and you'd probably have a better time kind of understanding what we were doing. So I'm just going to do the best I can. So the horizontal axis is this one. I'm sure you guys know. This is horizontal axis because it goes sideways horizontally. And the vertical axis is the one that goes up. So we are going to, it says experience is on the horizontal. So we're going to write EXP for experience. And wages are on the vertical. So wages. Wage. Okay, I can only fit wage there. So now let's see. We're gonna find data points. So we had wages was the first one, and then experience. So let's see here. The biggest experience value we've got is 10. It's going to give us a sense of our scale. And then the biggest wage we've got is 20. Okay. So here's going to be 10. Here's going to be 5. Okay. And we're just going to do it as best we can. So the first data point we've got is 8, 1. So experience is 1 and wage is 8. I'm going to put these in red just so that they're, I guess it's about right there, something like that. The second is 20, 10. So it's a wage of 20 and an experience of 10. So we're going to do that right there. The third data point is 10, 2. So 10 high, 2 over. 10 high, 2 over, something like right there. Okay. The third is 12 high and 4 over. 12 high, 4 over, maybe right there. Sorry. The fifth is 16 high and 4 over. So we're going to be at the exact same place on our x-axis and a little bit taller. And then the last is 14 high and 6 over. So somewhere right here. Okay. So if you did something like that, that would be pretty good, but hopefully it looks less crazy and messy than mine. But each of those red smudges is a data point. I'm so sorry, those look awful. I feel like a kindergartner. Okay, So it says, draw a straight line that best fits the data points. So we're gonna take a ruler. I wish I could get this ruler out and let it. Okay. So you can see that ruler here. And maybe I can draw along it. Oh, I can. That's wonderful. And draw a line through those points. And basically the goal of the line is to get it through the middle so that there's not a lot of space between the points and the line that I'm drawing, okay? And it says, based on that line that you've drawn, what is the approximate wage of someone with 0 years of experience? So if we extrapolated this back, I think that we'd find that the probably get something like 7, or yeah, something like 7. Say maybe it looks like this is intersecting at about 7. If you had graph paper, if you had a better grid than I do, you'd probably get something exact, but it looks like 7 to me. Okay, so that's one of the nice things about linear regression is once you have that line, you can predict how other people who are not in the data set might their wages might look based on their experience, for instance. So for D and E, we're gonna work on those tomorrow. And yeah, our time is almost out and we haven't covered those. So we'll cover those tomorrow. And yeah, so let me pause right there and I will take questions. You are welcome to leave as soon as you want. You're welcome.
Will you post the slides today? I mean the video today?
I will post the video. It might not allow it, so I'm out of space. So I might delete the first lecture.
Okay.
I need to figure that out. The variance of the wage, something like 18.666. Awesome. You're welcome. Okay, Leon, how are you doing? Are you okay? Welcome. Ibrahim.
Thank you, Professor. Appreciate it.
My pleasure, man.
Yep. Thank you.
See you tomorrow.
Yep.